The number one peaks of solar activity, according to a Space Today report, involve a discovery by a group of scientists from the Center of Excellence in Space Sciences, India. They have identified a new relationship between the Sun's magnetic field and its solar cycle of sunspots. This relationship may assist in predicting when the next peak of solar activity is likely to occur. The researchers' work suggests that the maximum intensity of solar cycle 25 is imminent and likely to occur sometime in 2024. At times, the magnetic fields of sunspots are disrupted in violent events resulting in the birth of magnetic solar storms. These storms can release high-energy radiation, ejecting a large amount of magnetized plasma into space. To understand this, it is crucial to grasp that the Sun is composed of ionized hot gas known as plasma. When a large convection cycle occurs, and large plasma flows converge, they form complex magnetic fields within the Sun. These fields manifest on the Sun's surface as dark spots, comparable in size to Earth, possessing intense magnetism with a force about 10,000 times stronger than Earth's magnetic field. More intense solar storms can also cause serious damage to satellites, electrical systems, and our communication infrastructure when these magnetic storms are directed towards our planet. Analyzing solar cycle 25, the current solar cycle, it is highly likely that the peak of activity will occur in early 2024, indicating uncertainty in the estimate that could lead to the peak happening as late as September 2024. Number 2 meteor shower in November 2023, the Leonids, made a comeback. Known as a meteor shower or star shower, this phenomenon occurs regularly during this time of the year, pointing to a potential recurrence in November 2024. Despite the commonly used term, star shower, actual stars do not fall from the sky. Falling or shooting stars are, in fact, just fragments of dust grains that ignite upon entering our atmosphere, becoming visible due to friction. These celestial bodies, known as meteoroids, typically disintegrate in the atmospheric layers, creating the streaks of light commonly observed and referred to as meteors. If one of these bodies resists disintegration and reaches the ground, it is then considered a meteorite. The Leonids, as their name suggests, derive their designation from the constellation Leo, as that is where the meteors, often called shooting stars, appear to originate. However, these meteors actually come from a narrow band of debris left over centuries by Comet 55P/Tempel-Tuttle. These remnants are deposited along the comet's orbit, and every year in November, Earth either passes through or comes very close to this cosmic debris field. The dust particles, mostly the size of sand grains, enter the Earth's atmosphere at speeds around 70 km per second, becoming incandescent due to friction and giving rise to the luminous streaks commonly known as shooting stars. The only star truly involved in this phenomenon is our Sun, which over centuries vaporizes material from passing comets, forming the mentioned dust bands later crossed by Earth. It was thanks to the significant Leonid meteor storm in 1833 that Denison Holsted concluded that meteor showers are caused by fragments of space rocks scattered in a debris trail orbiting the Sun. 35 years later, Comet 55P/Tempel-Tuttle was discovered with an orbit similar to the one calculated by Holsted for the Leonids of 1833. Thus, it was easy to understand that the Leonid meteor shower was formed by dust particles left by Comet Tempel-Tuttle. As for the risk to our planet, if the orbit of Comet Tempel-Tuttle is similar to that of the meteors, is there a chance it might hit Earth, along with its fragments? The answer, at first, is no. However, during its passage through the inner solar system, this nearly 4 km comet comes only 1.2 million kilometers from our planet's orbit. For some, this isn't a reassuring sign, especially considering that Earth annually traverses the debris of various comets and asteroids. Our current technology doesn't allow us to see these debris trails in space with our telescopes, even though we know they exist based on the presence of these particles that traverse our atmosphere, reflected in meteor showers. This raises another question: does each of these meteor showers mean that a dangerous object is approaching Earth? The answer is not necessarily. primarily because the interaction of these clouds or debris trails with large celestial bodies like Jupiter can complicate matters. Jupiter can not only propel such a cloud toward Earth but also alter the comet or asteroid's orbit that generated the debris, diverting the object away or potentially putting it on a collision course with our planet. Number 3. Artemis mission prioritizing astronaut safety. The second phase of the Artemis mission has been rescheduled for September 2025, concurrently with the third phase set for the same month in 2026, as per an announcement from NASA, the United States Space Agency, on Tuesday, January 9th, this year. According to NASA's official website, 4 astronauts will venture around the Moon in the first crewed mission by NASA, aimed at establishing a long-term presence on the Moon and advancing human science and exploration through the Artemis mission. The anticipated 10-day journey will test the basic capabilities of human exploration in deep space by NASA, an American agency tasked with developing aeronautical technologies and space exploration. For the first time, the Space Launch System, SLS, rocket and the Orion spacecraft will carry a crew of human astronauts. However, some astronomers suggest that the Artemis mission may happen as early as this year, given the progress in technologies and the space race among billionaires. Therefore, the estimated mission could potentially advance to December 2024. The Artemis mission aims to conduct scientific research on the Moon, and according to NASA, the focus is on exploring space and conducting studies directly from the satellite. With a continuation of missions, the institution envisions building a lunar space station in the future called Gateway. Artemis 2, the second phase of the mission, involves a crewed flight around the Moon. On board the Orion spacecraft, astronauts Jeremy Hansen from the Canadian Space Agency, and Christina Koch, Victor Glover, and Reid Wiseman from NASA, will head towards the satellite. One of the professionals and associate administrators in the Department of Exploration Systems Development and manager of the Moon to Mars Program Office at NASA stated that the Artemis program is a long-term exploration campaign with the goal of conducting science on the Moon by having astronauts work and operate there. This preparation is essential for future human missions to Mars. It means that we must get things right as we develop and pilot our fundamental systems to carry out these missions as safely as possible in the space race. In August 2023, the world witnessed a competition to explore Earth's natural satellite with the landing of the Indian Chandrayaan-3 module on the Moon. In the current year, various countries have numerous launches scheduled on their calendars, including spacecraft, probes, and robotic explorers. The exploration of space is expected to be particularly active in 2024. On the first day of the year, the Indian Space Research Organisation, ISRO, launched a rocket carrying an observatory to study black holes and other astronomical events. Following this, on January 3, SpaceX's Falcon 9 rocket launched 21 satellites into Earth's orbit. In addition to these launches, the SLIM module developed by the Japan Aerospace Exploration Agency, JAXA, a small-sized probe, aims to demonstrate high-precision landing. Launched at the end of 2023, it may attempt a lunar landing on January 19. Expectations for this mission are high, especially since 2 recent Japanese missions failed in their attempts to land on the Moon. The United States NASA is also dedicating efforts to 2 robotic missions to the Moon, Peregrine and Nova-C. NASA contracted both modules from space startups. Peregrine, from the American company Astrobotic, was successfully launched on January 8, propelled by the New Vulcan rocket from the United Launch Alliance, ULA. Meanwhile, the second module, Nova-C, developed by Intuitive Machines, an American publicly traded company based in Houston, Texas, is set to depart in February aboard a SpaceX Falcon 9. These missions aim to explore the Moon using instruments developed by NASA and American universities. However, the first mission of the year planned by NASA, with the module expected to reach the Moon on February 23, was anticipated to achieve the first smooth landing by the United States on the Moon since 1972. It would also mark the first such landing by a private company in history. The Astrobotic module is flying independently, having been launched into space by the Vulcan rocket, which made its debut and entered the competition against Elon Musk's SpaceX. The Vulcan, developed since 2014 by the United Launch Alliance, a company founded in 2006 by aerospace equipment manufacturers Boeing and Lockheed Martin, is vying for dominance in aerospace transport with SpaceX. Another potential competitor for SpaceX is Blue Origin, founded by billionaire Jeff Bezos. The Asian giant, China, is also actively engaged in the race to reach the moon in 2024. The country plans to launch the Chang'e mission, aiming to become the first mission to collect samples from the far side of the moon and bring them back to Earth. This mission follows the footsteps of Chang'e-4, which landed on the far side of the moon, and Chang'e-5, which accomplished China's first lunar sample return. The preparations for the upcoming mission are progressing smoothly, according to a statement from the China National Space Administration in October 2023. The administration mentioned that the mission's relay satellite would be deployed in the first half of 2024. China has also advanced its Chang'e mission initially planned for 2028, urging greater global collaboration for the unmanned lunar expedition. During the International Astronautical Congress in Baku, Azerbaijan, at the end of 2023, China's Space Administration expressed its willingness to collaborate on joint mission projects with other countries and international organizations. This suggests that China and its international partners could work together on spacecraft launches, orbital operations, spacecraft interactions, and joint lunar surface exploration. As reported by Chinese state media, Beijing's expansion of international ties through space collaboration is part of its broader plan for international cooperation. While only a few countries, including Russia, Venezuela, and South Africa, have joined China's planned lunar research station so far, the year 2024 holds promises for further advancements in these collaborative efforts.